In this video, we're going to apply L'Hopital's rule to find the limit of an indeterminate form produced by a quotient of the form 0 divided by 0. It says evaluate the following limit using L'Hopital's rule. It says limit as x approaches 0 of 2x divided by tangent of 2x. So first thing we want to do is make sure that this is actually indeterminate. We plug 0 in on the top, we get 0. Plug 0 in here for tangent, and we'd have tangent of 0. So tangent at 0 would be 0 divided by 1, right? If you're thinking unit circle, because the y value is 0 and the x value is 1. And so you end up with 0 when you plug that in the calculator as well. Tangent of 0 is 0. So this is indeterminate. Now we're going to find the limit as x approaches 0 by using L'Hopital's rule, which says to take the derivative of the numerator separately from the derivative of the denominator. When I take the derivative of the numerator, I end up with 2. So I have limit as x approaches 0. 2 over derivative of tangent 2x. So I'm going to have derivative of tangent is secant squared 2x, but I have to multiply this times the derivative, because it's chain rule, of 2x. So I end up with limit as x approaches 0, 2, well, derivative of 2x is 2, so the 2's are actually going to cancel there. So I end up with 1 over secant squared 2x. Now I need to evaluate that, so I'm going to say that that is equal to 1 over secant squared 0. So what is secant squared of 0? Well, I could write this as 1 over cosine squared of 0, because they're reciprocals of each other. Cosine squared 0, I know cosine at 0 is 1, so I end up with 1 over 1 squared. Well, this is all just going to equal 1. So then I have limit as x approaches 0 of this function, I'm going to call it f of x, just so I can save some writing. Limit as x approaches 0 of f of x, the original function, is equal to 1. And that's an application of L'Hopital's rule.